We work on things where bacteria live and thrive in the absence of oxygen, and we try to understand what it is that they are respiring and how it is they do it. My name is Dianne Newman. I am a molecular microbiologist. I am passionately interested in the coevolution of metabolism, bacterial metabolism, and the environments in which bacteria live. And this interest has taken me on a journey from caring about ancient sedimentary deposits to modern day infections. The best example of how studying ancient microorganisms can be relevant for studying modern microbes can be found in our work today on a pathogen called Pseudomonas aeruginosa, which is a notorious opportunistic pathogen that is involved in many different infections that wind up inhabiting the lungs of individuals with cystic fibrosis. And this organism becomes physiologically resistant to conventional antibiotics because it goes into an altered state of existence, and it's surviving, we believe, in many parts at least of the lung under anoxic condition. Realizing that forces you to begin to ask, well, how is it surviving under these conditions? What else might it be utilizing? What other strategies might be necessary for its survival? And so that's what we're studying and making progress in. And we hope that this type of work ultimately will lead us in a direction where we might have the ability to come up with new therapeutic treatments against this organism. Bacteria are the greatest chemists on the planet. And you're like an archaeologist. You're trying to interpret them. You're trying to figure out what they tell you. For example, beautiful ancient sedimentary deposits such as this is called a banded iron formation, and this is from South Africa, and it's over 2 billion years old. It has these lovely layers of different forms of iron minerals interspersed with silicates. Their genesis is an enigma and has beguiled geoscientists regarding the story of how they formed. So we decided to begin to work with bacteria that we cultured in our laboratory so that we could study the process of iron oxidation at a molecular level. And so that, for me, is really exciting. It's a form of paleontology that traffics in molecules. In all earnestness, the impact this fellowship is going to have on me, and hopefully also by extension on my group, is just to add a little bit more wind in our sails and to remind us that despite whatever momentary setback may come, that there's reason to keep going, there's reason to be optimistic, and there's reason to keep taking risks.